one last Sato about the LLM tool for security. Go for it.
Thank you, Mario. First of all, thank you everyone to stick around until the very end. I wasn't expecting this many people to be still around. So yeah, and there is a reason why my talk is at the very end, because my project is a bit more about AI and usage of LLMs and a bit less about blockchain as such. So it's a bit more generalizable. So yeah, my name is Satyajit Das, and my mentor's name is Frederick, and yeah, my project name is Differential LLMing. So in short, what it is about is basically comparing multiple Ethereum clients implementations of EIPs. Okay, so what's the motivation behind it? So various Ethereum clients implement specs or EIPs in their own ways. Sometimes there might be bugs or edge cases which they might have missed, and those are usually found out during, let's say, DevNets, so much later after they have actually implemented it. So what if we try to do something by using LLMs to make their lives a bit easier? So when they're actually implementing something, if they can get some AI-enabled feedback regarding their implementation of an EIP, then that might be useful for them. So things like spec tests exist, but we should also have other ways to look at implementation status. And because of the rapid growth of LLMs and AI in the past years, it would make sense to see if they can be useful for these sort of cases or not. Also, one more thing, why it is called differential LLMing. So yeah, the idea is to compare between clients and also to see if the clients can learn from each other. So for example, Lighthouse might have implemented the same feature as Prism, but in a different way, which might be a better way than Prism is doing, or vice versa. So if there is an automated way to find this out, that would be great. Okay, so the goal of the project is twofold. So the first step, before we can compare the status of implementation of EIPs across clients, we should be able to know the status of implementation of EIPs in one particular client. So the idea is to first get a proper report of the status of EIP implementation for one client and use multiple reports to simply do the comparison. So you can see the input would be like a EIP or a spec doc, and the output will be twofold. So per client reports and a comparison report. So here is a rough timeline. So initially I had a different approach which I presented in ETHCC. So those of you who were present in the ETHCC, so you might remember. So I had an approach which turned out to be quite more complicated than initially thought of. So during June and August, I was actually starting to implement that approach. Later I realized, okay, there is a much simpler way to implement it. So around the end of August, I talked with my supervisor, and we had a change of approach, which is much simpler. So I spent September and October to actually implement it, and November mostly testing it. So what is the approach? Before I talk about what was my eventual approach, let's talk about the completely naive approach. So what is the most naive approach you can think of? So you take the client code base and you take the EIP doc and dump it completely into LLM and ask the status of it. That is the most naive approach because the code base can be of the order of 10 million tokens. I think Geth is like around 25 million tokens, and LLM context length is only around 200K. So there is no chance that can happen, that can work. The other approach can be that assume that the LLM already knows about the code base and just feed it the EIP and ask whether this EIP is implemented properly or not. That also doesn't work because the LLMs are trained for code bases, but those trainings happened long time ago. And the client code bases, they are updated almost every single day. So these two sort of naive approaches don't work. So in a proper approach, we need the approach to be scalable. We need it to be ideally parallelizable. We want it to work independent of code bases or any arbitrary spec documents. And it should be able to support frequent runs. So what's the key principle of the approach, which I will talk about later? So I'm trying to, my aim was to basically replicate how a human coder actually searches for a particular feature in a code base. So if I simply give you a spec doc, what are you going to do if I ask you to check the implementation status? You'll probably search with some initial keywords, and after those keyword search, you'll find, okay, these are probably the files which look useful. Then you'll start looking for the implementation inside those files. And if you find something interesting, then you might be able to tell, okay, this is actually implemented or not. So this is the key principle I'm trying to implement. So the details of that. So the first step is to actually parse the EIP doc or the spec doc into a set of requirements. So each requirement can be of various kind. It can be a constant, a function, or a field, or RPC. And then, so that's the first step. In the next slide, I will show you how exactly a requirement schema looks like. The second step is to actually produce a set of aliases or keywords, which can be useful for the initial search. So one example is that a requirement might have been defined in the form of a snake case, but it is actually implemented as a camel case, or it might be implemented as a pluralization. So we need to have enough amount of aliases so that we can actually do a proper search before we are able to use LLMs inside this. So the first step is to actually parse it to requirements, then produce certain variations or aliases of the names. And then we do the search out of those names, out of those aliases. And then finally, we have gathered enough evidences. By evidences, I mean relevant code snippets or the files themselves. So once we have relevant code snippets or the files, then we're in a position to actually use the LLMs. So what we are doing is for each of those requirements, we're feeding these requirement itself and like the evidences one at a time. And because we're doing it, because the requirements are sort of independent of each other, so the program itself is parallelizable. So, and then once we do for every single requirement, then you can combine all of those to produce one single report for one client. And once we have that report, then you can compare those two reports of multiple clients to actually check the differential among them. So yeah, this is a brief summary of what I just said. So we start with a spec doc, then we convert it into a set of requirements, and this is how a requirement schema looks like. So each requirement has ID, kind, name, aliases, description, which is very important because this is how the LLM will actually know what that requirement actually does, pseudocode, if any, and there's another field called depends on for the cases where various requirements have interdependencies. And then, as I said, we produce aliases and use those aliases to actually do the searching. Then we gain the evidences, and then we feed to LLMs one at a time, and then we produce the report. So I'm going to show two results which are sort of representative of the current status of this project. But before I do that, yeah, let's talk a bit about the setup. So I'm running this for Prism and Lighthouse for Fulu specs. So I basically picked one of those spec docs for Fulu. I'm running Qwen 3 Coder 30 billion parameter large language model, which is running locally on my laptop. I wanted to save some API credits of Ethereum Foundation, so I just decided, okay, it's just better to run it locally as much as I can so that the agentic workflow is optimized before I actually start burning cash through using this API credits. So yeah, I'm using MacBook Pro M4 Max, and it takes around 4 hours for one full spec doc to run. And the comparison code is actually relatively faster because we are simply comparing two files. Okay, so this is the first result I'm going to show. This is what I did here is for a particular function in Prism, I introduced a bug. So as you can see, it should be actually division, but I created a multiplication. And I don't know if you can see this or not. The LLM gives a verdict that it is partially implemented because this does not match the specification of the pseudocode exactly. So what this means in the grand scheme of things is that there are like, 15 different clients now, if you include the Lean Ethereum clients, and every single client follows a spec document. So imagine a scenario where automatically detecting any sort of obvious bugs whenever the clients are implementing any feature. So I think this is at the stage where this actually can be useful to find these obvious bugs. The second result I'm going to show you, that is from a comparison report where it is comparing Prism with Lighthouse. This here claims that, okay, there are minor differences in byte order handling, and it also gives a recommendation of standardize the use of U256 arithmetic. So both of these might look like decent advices, but they are actually not. And it is partly because the LLM itself is not that strong. So it is a 30 billion parameter model. The top models are around like 1 trillion parameter models. So, but this program is at a stage where I can actually start using Anthropic API, for example, so that we can have at least better reports, better comparison reports than this. Okay, so some future work. So I would like to do more testing and some bug fixes. I would like to run with a better LLMs, as I just mentioned, run on GPU for VLLM. So currently I've been running it on LM Studio on my laptop, and LM Studio only supports one request at a time. So that's why even though my program itself is parallelizable, I can't actually take advantage of that. Whereas if I run it on GPU, then I'm able to run it with something called VLLM, which is an inferencing engine, which can actually parallelize those requests. Then another thing I would like to do is fine-tune local model with latest programming language version and client code base. So programming language version is also very important. One example I found out is that the program told me that there is a bug in Prism, but that was actually a bug for Go 1.22, but currently the latest version is Go 1.25, I think. So for a previous version, it can be a bug, but for latest version, it may not be a bug. And yeah, the LLM was probably trained a long time ago on 1.22. So this is why it might be very important to fine tune with the latest programming language version. And I would like to modularize the code base a bit so that it is more maintainable and better context management. And the idea is to eventually have some sort of GitHub automation so that the program can run, let's say, weekly for per client code base so that it can generate reports regarding the status of Glamsterdam, for example, in future. So yeah, that was about my main work, but yeah, I'd like to show a little bit of my side work. So I created a spec knowledge graph visualizer where you can easily visualize the entity relationships of various entities for Fulu. I would like to maintain that in the future as well. So yeah, thank you everyone. Thanks Josh and Mario.
Thank you so much, Sato. Do we have any questions for Sato? I see a couple of them. Awesome. Yeah, you're first, so sorry.
Hi, Sato. Nice presentation. So I'm curious about what's your method of training that, for example, when new specs is updated, do you need to make completely new model, or you can retrain that one because of false information?
So there is actually no training involved in the entire cycle,
Okay.
which I mentioned. So the starting point is always a spec document. It looks at it fresh. So it doesn't assume that how it looked like before. So let's say a spec document update happened today, and you run it with the latest one, it will do the entire cycle from scratch. So yeah, there is no actual training involved.
Okay, I understand.
Thanks, Sato, for your great presentation, and I found this can be very, very useful tracking for all those different implementation in other clients. So yeah, it's really great. And I have a question for other approach about the investigating the current implement status. So can we integrate GitHub API for each client team that search for EIP XYZ and then feed them to LLM that, oh, this is the diff from like Pure DAS or something?
You mean it will find out how exactly PeerDAS was implemented?
Yeah, looking for the GitHub PRs.
Yeah, so the GitHub PR, that is one of the ideas which I didn't end up implementing, but yeah, I mean, it is technically possible to do that, what you're describing. Yeah, that can be useful.
Any more thoughts, questions? Yeah. Okay. Yeah, I wonder, like, working in Prism, right? And now, do you actually use the LLM in your daily work? I wonder maybe like how practical you find it, maybe considering false positives or just generally running it in the GitHub PRs, whether you somehow integrated it?
You mean like writing code or reviewing code? Because
Like in the PRs in Prism, for
yeah.
example, whether there is some integration
Yeah,
that you tried?
there is an integration which uses LLMs to create PR reviews. Those haven't been as helpful so far. So the underlying language model really matters. So there are only like top 2 or 3 language models which are actually useful for a senior developer. I can imagine. I would imagine those automated PR reviews. Yeah, the corresponding model is not strong enough. So yeah.
Yeah. Okay. There is one more.
I know that a lot of clients have hard time with code reviewing. So how far away are we with getting involved like LLMs in code review?
I'm not sure how many teams are actively working on it. So the current autopilot code review, that is not as useful. So
maybe
my guess is if somebody takes a first principle approach when it comes to code reviews, so there are multiple ways to do or automate code reviews. You just take the patch or the diff of that entire code review and just feed it to an LLM and hope for the best. That is a good start, but that's not useful. That's not that useful because it may miss a lot of context. So the LLM or whoever is actually making the decision, they should actually know the current status of the code base so that it can make such certain form of judgment. So by first principle approach, what I mean is that mimicking a human developer as much as possible, because a senior developer will always do very excellent code review. Why? Because he knows the moving parts, he knows what's the latest changes, he has a historical contextual understanding, and he knows what sort of patterns we implement. And obviously, he knows to look for obvious bugs if things are implemented or not. So all of these actually have to be part of this entire workflow. If we are missing any one of them, it may not be useful. And my guess so far is that the companies which are doing these automated PR reviews, they probably don't have all of these. Otherwise, we wouldn't need human code reviewers currently, but actually we really do. So yeah, we are a bit far from it, I think.
Okay, thank you.
Okay, thank you guys for questions. Thank you so much, Sato, again for your presentation, for the great work. It's a very unique project, so you are the one to close it today. Thank you so much. Yeah.
Thank you.
And yeah, thank you so much, everyone, again for all the amazing presentations today. It's been a long day. It's been a wonderful day. We had 21 presentations today, probably. So many fellows, many projects that we've seen today. Thank you so much again for all the wonderful work and all the presentations you prepared and trained and have been working on in the last few days and weeks. I saw that so much effort went to not just the projects, but the presenting itself. So really appreciate it, guys.